Now I want to teach you a new topic today, and the name of that is Dalton's law of partial pressure. Dalton's law of partial pressure. So what is this law all about? What is this law all about? What is this law all about? What is Dalton's law of partial pressure? So basically, suppose you are having certain gases in different containers. Rather, let us consider like this. Suppose this is a container, right? And I am trying to fill different gases, but one at a time, whose volume is V and temperature is T. That is fixed. That is the property of the container. It is completely closed. It is rigid. Suppose I am filling oxygen first, and then I am removing oxygen by measuring the pressure inside it. Thereafter, suppose if I added helium, I'm adding, that time there is no oxygen, only helium. And then I'm measuring the pressure for the helium. And then, my dear, I'm adding some other gas like neon, again in the same container. I'm measuring the pressure. So suppose if different gases are, not simultaneously one by one filled inside the container, and the pressure, their pressure are P1, P2, P3, and so on, then what will happen if they will be mixed together? What will be the final pressure? Right? इसके बारे में ही ये पूरा law है, Dalton's law of partial pressure. But important point is that it is valid only if the gases are non-reactive in nature. What do I mean to say? Suppose you added ammonia and HCl. Guys, both are gas. At room temperature, both are gas. HCl is also gas and ammonia is also gas. When you dissolve, when you mix them together inside the container, so you will expect that inside the container, the pressure will be because of both of these. But the right answer will be they will combine. And if you took initially equal mole of them, then they will form a solid and they will settle down at the bottom. So basically, there will not be any pressure inside it. So it's very important that gases should not react. Okay. So what is Dalton's law of partial pressure? Okay. When a mixture of gases, or simply you can write in this way, when two or more non-reacting gases are mixed, when two or more non-reacting gases are mixed together. It is very, very important, guys. If you forget this word, non-reacting is very, very important. When two or more non-reacting gases are mixed together in the same container, then total pressure of the mixture of gas will be sum of their individual pressure. Sum of their individual pressure, and it is a better word to use the word partial pressure. Mathematically, that is equal to total pressure of the mixture is equal to the sum of different gases taken. जितना भी गैसेस इसके अंदर लिया हो. सो जहां पे P1 क्या है बेटा? Pressure exerted by gas 1, and P2 is similarly gas 2, P3 is similarly gas 3, and dot dot dot. Pn refers to gas n. Now, how to derive it? It is very, very simple, guys. As I told you that in the same container they are mixed, right? So partial pressure, suppose just one gas I took, one at a time. Inside the container, whose temperature and pressure is fixed. If one gas is taken inside, right? So what is the proof? So simply suppose if one component is taken, what you can say? Sir, P due to first gas will be what? N1 RT by V. Yes or no, guys?
Yeah.
Yes.
P2 will be what? N2 RT by V. P3 will be what? N3 RT by V. And similarly, my dear, dot 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 dot. Pn due to nth gas will be number of mole Nn RT by V. So guys, so when you will mix all of them together, that means inside the container we are having N1 plus N2 plus N3 because they are non-reacting. So number of mole will be like this. This is the mixture of non-reacting gases. Then P total will be what? N total into RT by V. Yes or no, guys?
Yes.
Now, if you look at this Pt is simply n1 plus n2 plus n3 plus dot 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 plus nn into whole RT by V. So यहाँ से आप देखो Pt को मैं अगर सिंपली करूँ तो n1 RT by V plus n2 RT by V plus n3 RT by V plus dot 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 nn RT by. So you can see this is nothing but P1 plus P2 plus P3 plus dot 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 plus Pn. That is what the total pressure of the mixture. Understood? So this was the proof. Now can we make use of it? I mean, let us say in this way. Can we say that what will be P1 in terms of total pressure? So P1 divided by total pressure. How much will be? P1 was how much? So guys, P1 was how much? N1 RT by V, and whole divided by how much is Pn? How much is total pressure, guys? So total mole into RT by V. Yes or no? So if you can, because the temperature, because the container is same, so temperature volume is same. So this will be basically N1 upon Nt. And this N1 upon Nt means what? N1 upon N1 plus N2 plus dot 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 plus Nn. So don't you think that this is nothing but mole fraction? Yes or no?
Yes, sir.
You remember mole fraction is what? The ratio of mole of first gas, first component to the total component. So from here what we received, P1 upon Pt is equal to mole fraction of 1. So P1 is equal to x1 into total pressure. This is really important. Alright guys. And similarly, my dear, P2 is equal to x2 into Pt. P3 is equal to x3 into Pt. Yes or no? And it will keep on going like this. Pn will be xn into total pressure. Right? So this is how you can look for this gas combination which are non-reacting. And now one question I would like to ask, if you have understood the things well, for which of the following mixture of gases we can't apply Dalton's law of partial pressure? Right. Option A is a very famous example. It may have more than one option, guys. Right, understood. It is understood that it is applied not at very high temperature. Right. So the correct answer for this will be, would you like to say anything? Any one of you? Guys, am I audible?
Yes, sir.
Yes.
So the first will react and form ammonia solid, ammonium chloride, which is a solid. Second thing, CO plus Cl2 also reacts. Basically, halogen, if you have taken, that have great tendency to react. So that forms COCl2, phosgene. Although that is gas, but still they are reacting now. So number of particles are getting affected. 1 plus 1 becoming 2 becoming 1. So similarly, my dear, SO2 and Cl2 also reacts. Right. But H2 plus N2, no reaction. अमोनिया मत बनाना है इससे. क्यों है साहब? Due to it requires a very high temperature and catalyst. इसलिए आप हाइड्रोजन नाइट्रोजन को ये अमोनिया मत बनाना. So the yes, that will be our. So we can't apply the Dalton's law. So answer will be A, B, and C. We can apply for D, but we can't apply for partial pressure. We can't apply for these three. I hope you understood. Now let us check few by how much you have understood with the help of few problems. For example, if suppose equal masses of oxygen and helium are taken in the same container, it would be better if I'll add one more gas. So equal masses of methane, oxygen and helium are taken together. Again guys, methane does not catches fire immediately with oxygen unless it is burnt, ignited, it doesn't catch. So assume that it is free. And if you want to be very sure about it, then use nitrogen. Nitrogen is also almost inert. There is no question now. So CH4 and 2L helium are taken in the same container. What fraction of total pressure exerted by helium? So if equal masses of these three gases are taken in the same container, then what fraction of the total pressure exerted by helium? That is my question.
28/39.
Hmm. तो कैसे करना है बच्चों? That is really simple. Now we are having all three gases, basically O2. Sorry, O2 is not there. So we are having methane, nitrogen, and helium. In the same container. So if it is like that, so equal masses are there, guys, M, M, and M each. Now what will be the mole of CH4? M upon 16. Agree or not? Kritika,
Yes, sir.
you have any class?
No, sir. That class cancel.
Okay, so number of mole of helium will be equal to what? M upon 4. Agreed? So very simple. It is basically asking what it is asking. It is asking what fraction of the total pressure exerted by helium. Basically, it is asking PHE upon P total. Yes or no? What fraction of total pressure exerted by helium? Basically, the ratio of these two. Yes or no?
Yes, sir.
Yes.
So pressure of helium is how much, guys? You know, that will be equal to mole fraction of helium, which means number of mole of helium divided by mole of helium plus mole of nitrogen plus mole of CH4. तो क्या आएगा बच्चों? वेरी सिंपल. Number of mole of helium is M by 4. So M by 4 plus M by 28 plus M by 16. Now you just simply solve it. So M will be cancelled out. Multiply 4 with in numerator and denominator. What you are going to get? You will get 1. आप 4 से ऊपर नीचे मल्टीप्लाई करो, देखो क्या आने वाला है. So you will get basically 1 and mm is cancelled out. So 1 by 7 plus 1 by. Agreed or not, guys? Yes or no?
Yes, sir.
Yes.
Now take the LCM 28 and then 28 plus 4 plus 7 and a big. So the right answer will be 28 divided by 39. So this is the final answer. So fraction of the total pressure exerted by helium will be this value. Agreed or not?
Yes, sir.
Yes.
Right. So this is how we used to convert it. We used to solve it. एक क्वेश्चन और दे रहा हूँ, देखता हूँ आप क्या करते हैं. based on this only. Three gases, helium, neon, and argon, are mixed in a container, right? Are mixed in a container, and the total pressure of the mixture is observed to be the total pressure of the mixture was observed to be how much? Of mixture was observed to be, say for example, 2018. If the mole fraction of helium and neon are 0.2 and 0.3 respectively, then what will be the pressure exerted by argon? Right? That is my question. Could you please solve it?
10 atmosphere.
How much?
10, sir.
10 you are saying. Okay guys, so I think I should solve it now. So we are having Manasvi, did you get the answer?
10, sir.
Good. So we have now three gases, helium, neon and argon. Guys, mole fraction is given as 0.2 and 0.3. So as you know that sum of mole fraction of each component is 1. Yes or no, everyone? So our first role will be to figure out the mole fraction of argon, which will be simply 1 minus 0.2. That will be 0.5. Once the mole fraction is known, can't we figure out partial pressure due to argon will be equal to mole fraction due to argon multiplied by total pressure. Total pressure is how much? 2018. So whole thing will be 1018. Yes or no? Guys, agreed or not?
Yes.
Yes, sir.
Yes, sir.
Okay. So now let us study about one more important term, which is known as vapor density. Density and vapor density of the gas. So as you know it already that PV is equal to nRT. And if I'll ask you what is the density of any material, you know a very regular formula, density is the ratio of, sir, mass by mass and volume. Right? So density is the ratio of mass and volume. So it is valid for everything, solid, liquid or gas. So volume is there. If anyhow we get mass and if we take the ratio, we will get. So guys, from here, if you just write like this, P is equal to, P is equal to, number of mole is what? Mass by molar mass of the gas, yes or no?
Yes.
So from here, P into M is equal to small m by capital V into RT. And this is nothing but density into RT. So density is simply PM by RT. Very, very important relationship. Why I'm saying this? Why I'm saying this, guys? Because for gases, density does depend on pressure and temperature. Greatly affected by temperature and pressure. सोच लो आपका सेम गैस है बेटा. Suppose you have the same gas. That means molecular weight of the gas is fixed. But if you change the pressure from 1 atm to 2 atm, simply by changing the pressure will increase the density provided the temperature is constant to double. That impact will never be observed when we are having any normal thing, any normal solid or liquid. When you apply the pressure from P to 2P, it will not compress. So it is happening just because the gases are highly compressible. There are too much space, right? So we can compress them together. So this is density, guys. And now then what is vapor density? So there are, okay, ratio of the density. Or you can say relative density. So there are two such terms is defined which are very, very popularly used. You would have heard about specific gravity. Number one. And number two, which you would have heard, is vapor density. So specific gravity of anything is the ratio. It is the ratio of density of substance to the density of water at 4 degrees. So for example, if suppose I am saying a solid having specific gravity 1.5, it means that density of solid is equal to divided by density of water at 4 degrees centigrade is 1.5. Basically, density of solid is equal to 1.5 multiplied by density of water at, so at 4 degrees centigrade, the density of water is nothing but 1 gram per ml or 1 gram per cc. So this is simply 1.5 gram per, per ml or per cc. That's what the specific gravity actually means. So if the specific gravity is known, you simply write gram per ml, that will be the density of that substance. Now, when it comes to vapor density, guys, so vapor density is a ratio. It is the ratio of density of the vapor of a particular substance it is the ratio of density of vapor of a substance to the density of density density of vapor of a substance to the density of hydrogen, unless it is spoken something else like relate vapor density with respect to oxygen. By default it will be with respect to hydrogen, but if they are using the word that with respect to oxygen, then this you will change. So in correct way, it is the ratio of the density of vapor of a substance with respect to defined gas, any defined gas. So if nothing is mentioned, I will simply use hydrogen. It is denoted by the symbol capital D sometimes, VD or capital D. So my dear, capital D will be what? Density of vapor divided by density of hydrogen, unless it is said something else. It means this only. Now the question arises, sir, as you said that temperature and pressure will greatly affect the density of the hydrogen. So are they at different temperature and pressure? No, guys, at same temperature. If you want to add, you can add the density of hydrogen at same T and P, same temperature and pressure. Guys, am I audible?
Sir, yes.
So here, if you write it down, you will figure out density is pressure into volume, into molecular weight of vapor divided by R into T. That is how the density of the gases are defined. So pressure into molecular weight of hydrogen divided by R into T. Everything get cancelled out. Density will be molecular weight of vapor upon molecular weight of. So molecular weight of vapor will be equal to vapor density multiplied by molecular weight of hydrogen. And that is how you remember molecular weight of vapor is equal to 2 into vapor density. So this is one of very famous relation of molecular weight. But what you need to make a note, if vapor density with respect to oxygen is capital D, then molar weight of vapor will be molecular weight of O2 multiply by VD. I hope you are understanding, right? क्योंकि अगर
Yeah.
O2 के रेस्पेक्ट में पूछ दिया तो O2 का मोलर मास रखना पड़ेगा, which is simply 32 multiplied by vapor density. So this is very, very important. Unless it is mentioned something else, you are supposed to take hydrogen by default. But if something else is mentioned, then you have to take that as a reference. So many a time this type of question is asked. Okay. So एक छोटा सा क्वेश्चन मैं पूछ करके ये खत्म करता हूँ टॉपिक. For O2 gas at which condition of T and P will have higher density? Option A, NTP. Option B, STP. Option C, 2 atm, 0 degree. Option D, 4 atm. And temperature, let me take as 819. Tell me the right answer.
Option C, sir.
Option
C,
C.
sir.
Okay.
C.
C, sir.
Okay. So let's look at how we have to think. Very simple. Means density is equal to Pm by RT. So molecular weight and R is fixed. So density proportional to ratio of P by T. Just figure out the ratio. NTP means pressure 1 atm, temperature 273. Ratio P by T will be 1 by 273. STP, you know, P by T will be pressure 1 atm था ना, तो atm में आपको मालूम है approximately not exactly, but you know STP पे pressure is 1 bar. So 1 bar is 1 upon 1.013. अगर मैं atm वर्सेस केल्विन करूं, whole divided by 273, which is approximately same 1 upon 273. A third condition C is 2 atm divided by 273. So this appears to be larger than that, and similarly for D you can compare. That is 4 atm divided by 900 and something, 819. So 819 Kelvin, and if you simplify this will be 2 divided by, right, how much? How much, guys?
404.
Around
3 by 2.
0. We can see this is much less as compared to this. So the correct answer will be C, which is pressure 2 atm and temperature 273 Kelvin. So guys, can't you plot the graph of density with respect to pressure if the temperature and molecular weight is constant? Can't you plot this? If the molecular weight and temperature is constant, can't you plot? एक लिख रहा हूं, आप करो. So draw the graph between, right, density of ideal gas versus pressure. Constant. So isn't it density and pressure will be what? Linearly related. Yes or no?
Yes,
Right.
sir.
So this is density, this is pressure. Very simple, because D is equal to Pm by RT. So if these parameters are constant, so basically K into P. So where tan theta will be simply M upon RT. Yes? So in that way, you can figure out everything, guys. So I hope you
So
understood.
guys, if you want more videos like this, like, share, comment and don't forget to subscribe for